Okay, guys, today we get to start our new unit. This is about exponents, one of my favorite. Wait, no, everyone's my favorite. So in math, when it comes to algebra, just love them all. So let's look at what's going to be happening. We're just going to look at 4 rules for today. We're going to talk about the product of powers. Product, remember, means multiplication. After you multiply, you would get an answer, but that answer is because you did multiply. Okay, so let's see where some of these rules come from to begin with. So we all know that x times x times x is equal to x to the third. Yes? Good. Now if I take x to the second times x to the fifth, I want to show you what we know is true. We know that that would be equal to x times 1, 2, 3, 4, 5. Right? All those x's, right? Now, let's do what we did over here. That'd be 1, 2, 3, 4, 5, 6, 7 x's. So that's x to the 7th. What I want you to do now is look at these two numbers here. What could I do to those two numbers to get this? What could I do to those two numbers to get this? Hopefully you said add. And that's what our first rule is saying, that when I multiply like bases, I add the exponents. And what we mean by like bases is if I would have x to the second times y to the fifth, that's just x to the second, y to the fifth. These are not like bases, so I cannot do anything else with it. Okay, so let's look at some examples. If we have x to the fourth times x to the 11th, x to the fourth times x to the 11th, I am multiplying like bases, so when I multiply like bases, I add the exponents. Now this step I don't normally write down, but I'm doing it just for today for our notes. When I multiply like bases, I add the exponent, so I get x to the 15th. Okay? Number 2, y times y to the 8th. Now on this one, what you need to remember is what is my exponent right here? Hopefully you said 1. And if I take y to the first times y to the 8th, that's y to the 1 plus 8, or 9. Let's put some coefficients in there. So we have 3x to the second times 4x to the fifth. Coefficient, 3 is a coefficient, 4 is a coefficient. Coefficient is the number that is connected by multiplication to the other terms. But it is a number out in front, but it's connected by multiplication. So what you need to remember is I still multiply those like I always would. 3 times 4 is 12. Now I have like bases, and when I multiply those, x to the 2 plus 5 is x to the 7th. Oh, we've seen that before. Okay, here's one that sometimes throws people off. If I have 3 to the second times 3 to the 5th, these are like bases. I'm stuck on 2's and 5's today. Did you notice that? 3, these are like bases. So that just gives me 3 to the 2 plus 5, or 3 to the 7th. And then you pull out your calculator, and hopefully you all know how to do this. So I'm going to take, see this little caret key right here? It would be a caret key in English class. But this is our exponent key. So I'm going to take 3, that button, 7, okay? And see how I get 3 to the 7th power? That would give me 2,187. Now we can't simplify these anymore because 12 is not to an exponent. It's only this one. And I know sometimes people will go, but you didn't take the 3 times the 3. Shouldn't that be 9? No. By adding the exponents, you did multiply the bases. Okay? Let's move on. Quotient. Quotient means division. Divide. Okay? So here we have x to the 5th over x to the 3rd. Now let's do it like we did it up here. Let's write it out. So that'd be 1, 2, 3, 4, 5 x's over 1, 2, 3 x's. So now what we're going to do is we're going to simplify this. And if I have 1 on the top, 1 on the bottom, they cancel each other out. They divide out to 1. So what I have left is x to the 2nd power because I have 2 x's. So now, once again, look at these numbers, 5 and 3. What did I do with 5 and 3 in order to get 2? Hopefully you said subtract. Because when I have like bases, I'm just going to subtract my exponents. So let's try some subtraction. Let's try some division. If I have x to the 10th over x to the 2nd, That's going to give me x to the 10 minus 2, which is x to the 8th. Okay? I don't have to write this step. I do it for notes just to see it. You won't see me do that again unless I need to emphasize something. So here we go, our next problem. We have 12 x to the 11th over 2 x to the 9th. Now when I see these problems, I see it as two different problems. Here's one, 12 divided by 2. I'm going to simplify that. Now I have x to the 11th over x to the 9th. I'm going to simplify that. So 12 divided by 2 is 6. And now I'm going to subtract because I'm going to divide. When I divide, I'm going to subtract my exponents. Now, as you know, I always come up with weird ways to remember things. When I look at how do I remember this? When I think about multiplication, I think that addition is one step back from that. One step back from what I learned here. When I multiply like basis, I'm going to take one step back. When I divide like basis, I'm going to subtract. I'm going to take one step back as far as what did I learn mathematically. Okay, I learned how to add, then I learned how to multiply, so I'm taking one step back. I learned how to subtract, then I learned how to divide, so I'm taking one step back. Okay, so number 3, I have 14 x to the 11th, y to the 7th, over 12 x to the 2nd, y to the 3rd. So again, treat it as three different problems. 14 over 12, x to the 11th over x squared, y to the 7th over y third. So if I have 14 over 12, now 12 cannot divide into 14, but I can reduce both of those by a 2. 14 divided by 2 is 7. 12 divided by 2 is 6. Now let's look at the x's. And here's the other thing that when I'm doing division, I always want to keep in mind is where is it bigger? That variable is going to end up on where it's bigger. It's bigger in the top. So 11 minus 2 is 9. Or I can also say I'm dividing, so I'm going to subtract my exponents. Y, bigger in the top, so it's going to end in the top. 7 minus 3 is 4. Okay? Good. Moving on. We're going to practice these a lot. So you're going to get it. So now we're going to go to the exponent of 0. So again, let me show you kind of an example of things that you know. If I have 5 over 5, what is that equal to? 1. Good. So if I have x to the 10th over x to the 10th, notice here you told me this was 1. That's because I had the same at the top and the bottom. So I have the same at the top and the bottom. So that is equal to 1, yes? Okay, now, look at this right here. If I have the problem x to the 10th over x to the 10th, so I'm taking the exact same problem. Now, we just learned that when we divide, we subtract exponents. So this would be x to the 10 minus 10. Which would be x to the 0. Do you agree with that? Okay, I'm just following the rules. So now, we're going to kind of do a little transitive thing here. In some ways, it's transitive. Yes, it is transitive. So, I just found out that we just stated that this is equal to 1. And this is equal to this. So, we would actually have to say 1 is equal to that. X to the 10th over x to the 10th is equal to x to the 0. So, doesn't that mean that 1 is equal to x to the 0? It's almost like I did magic, isn't it? But I didn't. You saw the exact same steps that I did. So what this is telling us is x to the 0 is equal to 1. Because any number raised to the 0 power is always 1, except when the base is 0. Okay? And then there's some other funky things when you get into really advanced math up and beyond a bachelor's degree in college. There's some other wonderful things that happen. So let's look at some examples of this. 9 to the 0, guess what's it equal to? 1, exactly. X to the 0, what is that equal to? 1, we just talked about that. If I have, this is me being obnoxious, if I have, I'm using a pen to the 0 power, that's equal to 1. I'm just trying to emphasize anything to the 0 power is 1. Okay, let me go extreme on you. We have 1,000, x to the 10th, whoops, 20th I guess, y to the 5th, over 2,000. X to the 18th, y to the 20th, all of it to the 0 power. All of this, but it's to the 0 power, so it doesn't matter. That's still equal to 1. Okay, anything to the 0 power is 1, except, of course, 0. Okay, moving on. Negative exponents. So, with negative exponents, I want to show you, once again, I want to show you, kind of like what I just did. If I have x to the 3rd over x to the 5th, I can write that out to be x times x times x over x times x times x times x times x. And let's do what we did before. We're going to reduce this by taking out x's. So I divide out an x, I have a 1. Divide out an x, I have a 1. Divide out an x, I have a 1. So on the top, I just have a 1, and on the bottom, I have x squared. Okay? Is that legitimate? See what I did there? Nothing tricky? Just wrote it out. Okay, now I'm going to take that exact same problem. X to the 3rd over x to the 5th. We just learned that when we divide like bases, we subtract the exponents. So this would be x to the 3rd minus 5. Yes? That'd be x to the negative 2. Okay? Now, here we go. X to the 3rd over 5 equals 1 over x squared. And x to the 3rd over 5 equals x to the negative 2. So that means that 1 over x squared is equal to x to the negative 2. Now, most of the time, people are going to write it like this. They're going to write that negative exponent first. But it's true either way. Whoops, x squared. Okay, and here's the way I like to think of it. You can do this too, but that's just, okay. Negative exponents make the term go. I forgot a word there. That means to say go to, so go to its opposite place. And I'll show you what I mean by that, okay? So its opposite place. If it is, right now, it's in the top. It's in the numerator. Even if we don't have a denominator, we know there's 1, it's 1. It's in the top, it goes to the bottom. So the numerator goes to its opposite place, which is the denominator. And notice you have a double arrowhead there. So numerator goes to denominator, denominator goes to numerator. Now this is wonderful math jargon on how we can write that too. A to the negative n is a reciprocal of a to the n, which is what's right there. That's fancy talk for this. Okay, which is great. It's good to see all those words. It's good to go through that. So let's look at examples. If I have x to the negative 5th, that's equal to 1 over x to the 5th, because it goes to its opposite place. If I have 1 over x to the negative 2, see how it's in the denominator? It comes up to the top. Okay, so it goes to its opposite place. Here's another one. 3x to the negative 4. Now on this one, what you need to understand, the exponent on the 3 is a 1. It doesn't move at all. It stays right where it's at. But that x to the negative 4, it's in the numerator. It has to go down to the bottom, down to the denominator. Okay? Number 3, let's look at those. If I have 7 to the negative 3, I have a negative exponent. It goes to the bottom. And so you're going, what goes to the top? If there's nothing there, you're going to put a 1. And then that, you pull out your calculator. If you ever have a number to an exponent, we're going to just pull out our calculator. We're going to find out what that's equal to. And that's 343. So that's 1 over 343. Okay? Now what I like to do, if you were in class right now, is I look at that worksheet that you have. And we have this worksheet right here. And I try to find anything that looked somewhat difficult. And I wish you could be the one to choose it. Okay? So this is a mixed review is where I'm going to go to. And I'm going to pull one like that. So I'm going to make up one like this. So here, there are so many ways that you could approach this one, and all of them are right. Okay? So hopefully you followed through what I did here. Negative exponent sends it to the bottom. Negative exponent, when it starts at the bottom, goes to the top. Here, the 3 stayed, but the x went down to the bottom because it had a negative exponent. Here, negative exponent goes down to the bottom, so I have a 1 up top, and I multiply that out. So what we have here, once again, it's like we have 3 different problems. Okay? We have the coefficients, we have the x's, we have the y's. There's, again, lots of different ways you can approach this one. For me personally, I like to get rid of the negative exponent. So if I were doing that one, that's how I would simplify first. So I'm going to give you option 1. There are so many options. I would simplify first by just moving it around so that I don't have negative exponents anymore. Because we all know I'm bad with negatives and I drop them. So I have an x to the negative 2. That comes down to the bottom. Y to the 3rd stays up top. X to the 5th, it has a positive exponent. It doesn't move. Y has a negative exponent and moves up to the top. Now I'm going to simplify here. 14 and 7. 14 divided by 7 is 2. Y's are all up in the top. When I multiply, I add the exponents. When I multiply, I add the exponents. That's a y. So that's my answer. Okay? Let's see if there's another one that's kind of a tricky one. So here's another one I want to try. Okay? So if we look at this, 24 and 8, both divisible by 6. So I divide 24 by 6, I get 4. 18 divided by 6, I get 3. Now look at the x's. What I like to do is I like to see where it's bigger. It's bigger down here, and I'm going to subtract. As long as I place it where it is bigger, I can subtract either direction. So 5 minus 3 is 2. Y, again, I'm going to look to see where it's bigger. It's up top. You might have noticed I already wrote that down. So 7 minus 4 is 3. Okay? Good. I wish you were here in the classroom so I could say which ones look tricky to you. I'll make up one like that. So what I expect you to do is do your best on the homework today, which is this worksheet. Okay, it's the page right after. It's this worksheet. And then if you have questions, come in and ask me on Monday. Please just come in and ask me. I do want to do number 53. This one I think was kind of tricky, but it is so good for later on when you're doing, just to let you know, when you're doing logarithms. This is where it really comes into play. Okay, a long ways off. You won't even get to see them this year. Okay, so here we go. Here's where it's like a puzzle. All of this is like a puzzle. What I want you to realize is I have a 3 here. I have a 9 there. I'm going to rewrite this one to be a base of 3. That's 3 squared is 9, yes? I still have to fill in that box. So see how it's down in the bottom? Okay? If I want to get it up to the top, that has to become a negative exponent. So this right here is a negative 2. Okay? Negative 2 is what would go there. You have to realize you have to change it to another base. So let's do another one. If I have 1 over 36 is equal to 6 to something power. Ah, no, that gives you the same answer. Let me give you a different one. 1 over 81. They might not even do this. Oh, they do. This one happens to be number 59. And then it wants it up here. You have to write 81 as a power of 3. Okay? 81 is a power of 3. So 3 times 3 is 9. Times 3 is 27. Times 3 is 81. This is a power of 4. 3 to the 4th power is 81. So this right here is negative 4. Because I'm going from the bottom to the top, it has to be a negative 4. Don't worry about these too much, but try them. See how you do them. Okay? And I'll put the answer key out for these probably by the end of the day on Friday. Good. Thank you.